Welcome to the Rethink Vertical podcast, where we cut through the hype. This podcast brings you emerging aviation technology insight without the fluff, so you know where the industry is today to shape the future of tomorrow. Welcome to the Rethink Vertical podcast. Today's episode is sponsored by the UAS Cluster Initiative. Today I sit down with Kraettli Epperson, CEO of Vigilant Aerospace. Kraettli has a 25-year career as a software developer, systems architect, product manager, and technology company executive. His leadership in unmanned systems innovation is recognized in the industry, and he's a frequent expert speaker at major UAS industry conferences, addressing topics such as unmanned aircraft detection and avoidance, and UAS flight safety and airspace management systems. He's a selected member of the FAA's Aviation Rulemaking Committee for Beyond Visual Line of Sight UAS flight rules, and he's a member of the ASTM F-38 Committee and the RTCA on technical standards for unmanned aircraft. Kraettli is an FAA certified Part 107 remote pilot and has participated in numerous flight tests of unmanned aircraft systems, including flight testing at NASA Armstrong Flight Research Center and at the Oklahoma State University Unmanned Systems Research Institute. He is also the co-inventor of 4 technology patents. Vigilant Aerospace Systems is headquartered in Oklahoma City, Oklahoma, and was founded in 2015. The company's purpose is both licensing and commercialization of NASA flight safety technologies, and also developing and marketing new situational awareness, detect and avoid, and autonomous flight products for both manned and unmanned aircraft. Our conversation today was focused on beyond visual line of sight drone operations and where detect and avoid technology will provide a reliable safety parameter for fully autonomous operations. I hope you enjoy the episode. All right. Well, welcome to the Rethink Vertical podcast. Happy to have my guest today, Kraettli Epperson from Vigilant. Kraettli, really excited to have you on the program today and look forward to a really interesting conversation.
Thanks, Craig. I'm very happy to be here and looking forward to talking to you about the state of the art with drones.
Yeah, very good. One of the questions, I know we've talked about this before, one of the questions we hear a lot from folks that maybe aren't in the industry, aren't paying attention, are why am I not getting drone deliveries to my house right now? And so I don't know, you want to talk a little bit about maybe some of the challenges that we're seeing and some of the stuff that's going on?
Yeah, absolutely. We're all looking forward to that day when we can get a pizza or an order of tacos directly to our front porch or our backyard via drone. And hopefully that'll eventually happen. There are a lot of reasons right now in the U.S. where that is causing that to be very limited so far, but there is progress being made. So there are regulatory reasons right now why small drones are only allowed to be flown by the FAA within the visual line of sight of the pilot. And there are advances being made in regulations and new rulemaking that we'll get to talk about later, I'm sure, that are going to allow much longer range drone flights for small drones. And that's certainly going to be helpful for things like deliveries, customer deliveries to your doorstep. But right now, one of the major restrictions is that line of sight rule. So there are people that are doing some deliveries on a very limited basis. You may have seen headlines about this, and you may have seen, for example, Walmart has announced that they're doing some deliveries. Most of that work, though, is line of sight, or it's with a lot of restrictions. One of the important things about using drones for delivery is that they need to have special certifications to be an air carrier, to actually carry goods for people. So that's one type of restriction. And then the other would be that you really need to fly it beyond visual line of sight for it to be very useful. Otherwise, you can just deliver it
Right.
to your neighbor or your neighborhood, right? And so people are definitely experimenting. And we have work going on at our company to support that type of work. But we're really looking forward to some advances and changes in the regulations. And those really depend on safety. And so that's an area that we're very focused on, is delivering safety systems for drones of all sizes. And that's a really key market gap and technical gap right now that we're working really hard to fill so we can get our tacos to our backyard, patio party.
Right. I think that's an important point. So I think folks think about this, maybe they don't see the full picture here, is because what you're talking about is there are a lot of drone operations being done now, right? You think about some types of infrastructure inspection. You think about there are drones out there doing commercial operations. But when you talk about carrying something
Mhm.
for hire from another company, that puts it in a different bucket for the FAA. And so I think the safety requirements increase, and you start
Mhm.
talking about getting a type certification, all those other challenges. From the FAA standpoint, when you talk about the safety, you talk about operating out of line of sight from the pilot. One of the things we hear a lot about is sort of how does an aircraft that does not have a pilot on board, just has somebody controlling it from a distance, how does it avoid other aircraft, other airplanes, other drones? You want to talk a little bit about kind of that detect and avoid concept and kind of what you guys are doing at Vigilant?
Yeah, absolutely. So detect and avoid is a really key safety concept. It's the idea that drones need to be able to be aware of and then to avoid conflicts or collisions with other aircraft of all kinds, but especially obviously crewed aircraft. Helicopters, small aircraft that might be flying at a low enough altitude that they could have a conflict with a drone. And that's mostly what we're talking about when we talk about consumer drones that are used for things like in the future delivery, or right now that might be used to inspect power lines or to inspect wind turbines or reservoirs and dams and things like that, for which drones are being used actively. And so this idea of detect and avoid is a requirement that the FAA has, that drones be able to, and the remote pilot be able to be aware of other aircraft. And so that's called DAA in the industry. And it's a specific technical capability that's very important to the industry. And it is laid out in what are called the Part 107 rules. Part 107 is the rule that the FAA published that allows you to fly small drones commercially at low altitude, below 400 feet. And 107.31 is the requirement that the drone be flown within your visual line of sight. And so in order to not fly it within visual line of sight, you have to get a special waiver. And there are increasingly companies that are getting those waivers. And typically to do that, you have to have a way to know what other aircraft are around your drone when you can't see it any longer, right? So
Right.
it's flown beyond where you can see it. How are you going to know where the aircraft are around it? And there's a variety of ways to do that. There are sensors. Obviously, there's a lot of great sensor technology. And then knitting that together and providing that to the remote pilots so they can use it in a manner that allows them to fly safely is really important. And that's the technical gap that we're really focused on when we talk about detect and avoid.
Yeah. So there's two key pieces here that I see. You've got the aircraft or the pilot that wants to fly beyond visual line of sight that needs to be able to have sensors available to detect that aircraft. And then you have okay, whatever sensors that is, right? So we'll talk a little bit about radar or acoustics or all kinds of different things folks are playing with because of the cost of certain sensors. But the other piece is when they get that data, then what do they do with it, right? So they've now detected something. And so you want to talk a little bit about how you guys envision the certain algorithms you use to make sure these aircraft can actually miss other aircraft once they detect them.
Yeah, absolutely. So that's an area of specialty for us. Let me talk a little bit about the sensors first, because that's such an important frontier right now for the technology, and it's where there's a lot of development work, both really on the regulatory side and on the technical side. So right now, you have a requirement when you're flying a drone beyond visual line of sight to be able to detect aircraft that have transponders. So those are aircraft that we call cooperative because they're sending a radio signal out and saying, "Here I am, please don't hit me." And that is pretty straightforward because you can have a radio receiver on your aircraft or on the ground that can really detect that signal a long ways away, and that can allow you to detect those aircraft and avoid them. But equally important, there are aircraft that are not required to and don't have a transponder. And those are called non-cooperative. And so you can't see those aircraft with their radio signal. They're not sending anything out about "here I am." So you have to detect them some other way. And that's where these other sensors, physical sensors like a radar or an acoustic system or even a camera system, come into play, where they will either onboard the aircraft or sometimes, particularly with radar on the ground, be able to detect that aircraft beyond where the pilot can see it, but where the pilot needs to fly. So if you're inspecting a pipeline or you're inspecting a long electrical line or other sort of infrastructure, which is where a lot of this work is starting, you will often use a sensor like a radar on the ground so that you can see a long distance from your starting point usually, or you'll have a sensor on board. And so that's the really exciting frontier now. Those sensors are getting better all the time. We're a company that integrates with and uses those sensors as part of our software. And so our software, as you were asking, takes that data in, both from the radio transponders where aircraft are squawking. They're saying, here I am. And also from aircraft that are not squawking, that are not saying, here I am, you can detect them with the radar. And all of that gets put together and fused together into a 3D picture of the airspace. And then our software will tell you if there's an aircraft that has a risk of coming too close to your drone for safety. And then we'll provide you with information on what to do about that. It will provide you with an avoidance command. Yeah.
So how does the FAA, like right now, what is the FAA's thought process and how they do two specific things? What sensors are good enough and reliable enough for them to trust them? And number two, that the software that takes that data in acts appropriately, right? I know, thinking back to my days on the air traffic side, when you'd have aircraft that for whatever reason got too close to each other. Maybe the procedures weren't that great, or their controller missed something, and then they would have a TCAS alert, right? So the internal aircraft would see the aircraft through radar, and it would say it's going to avoid the aircraft. What's the FAA's stance on setting a requirement for the level of accuracy of that data to say we trust this stuff to be able to operate autonomously and see aircraft? Or where are we on that?
Yeah, absolutely. So there are several activities going on that we're aware of, and we've really had the fortune of being involved in helping to advise on some of the regulatory work through this process that the FAA uses called an Aviation Rulemaking Committee. And so I'll talk about that a little bit later. But right now, what's happening is, and the FAA is explicit about this in their Part 107 rules, for example, and then for larger drones, they have a separate set of rules where the FAA is offering waivers. So what will happen is industry partners who have a particular need to develop an aircraft and they want to create a specific type of operation will go through a process where they will select the equipment, including the types of things I've described for safety. They'll have a procedure, they'll have a training procedure, and all of that will go into a waiver request that can then support that company's ability to fly an extraordinary or advanced operation where they're going to fly beyond visual line of sight. And so what's great is that there's a lot of that activity going on right now. There are a lot of systems that are emerging, and these waivers are being granted, particularly for low altitude, what are considered pretty low risk flights, because they're not over or near people. They are in areas where, for example, you might be inspecting a power line in a rural area, and the power line itself is an obstacle, right? So aircraft don't want to fly through the power line. And so when you're flying your drone really close to those obstacles, the FAA has expressed a willingness through waivers to allow you to do that. And we're seeing more and more of that. And we're also seeing waivers where if you use a radar, like the type that we integrate with and use in our system, that you can get waivers for longer range, non-infrastructure, so you don't have any necessary obstacles. You're just flying where you need to fly, but you are monitoring air traffic with your radar. And that's already happening. So there are multiple projects that we're working on and lots of our partners are working on to begin to use these types of integrated systems and get those types of waivers and fly those types of flights in anticipation that these rules are going to emerge and it's going to become standardized. So we're really excited about that. And I can talk about kind of the process we've seen and been fortunate enough to participate in. But going back to that question of how you do safety, this is something we're really focused on. And we do use the latest version of the FAA's ACAS-X, which is a set of avoidance protocols that are accepted by the FAA. It means that they're things that the FAA has gone through a testing process with and said, this is the algorithm, these are the maneuvers that are taken when you have this type of conflict between two aircraft, and this is what you're expected to do. And you can use that for automatic automatically generating the avoidance maneuvers. And so the industry has that available now. It is a successor, as you mentioned, to the TCAS system that allowed aircraft, when they came into conflict, to quickly have warnings and have an alert and have a specific maneuver that they were supposed to take. And the next generation of that is now being used with drones of various types, including the small ones, but especially the big ones right now. And so we're involved in using some of those systems, and that's a great way to have a safety system that's understood, so you don't have to create it all from scratch, basically.
Right. All right, so I'm going to put you on the spot a little bit. So you talked about a lot of these waivers going out for lower risk operations, inspection operations. We've heard a couple different waivers recently. I think one that stood out to me was the Massachusetts DOT waiver for inspecting railway tracks, and it wasn't geographic specific. So they could do it anywhere in the state as long as they followed certain procedures and protocols, which I hadn't seen that before. So let's talk about what I'm hearing from the industry is like, that's all great, but the reality is a lot of these companies' business model require that they operate in more dense environments with more customers. And so when we talk about the sensors needed for the FAA to approve even waivers, not talking about scalable operations in a dense urban environment, whether it's a drone delivery or even inspection over lots of people. What's your take on the type of sensors, radar, no radar? We'll talk about UTM a little bit later. Kind of just want to get your thoughts on where you see the FAA going. Now, there's a big push to not require operators to have access to radar at low altitudes. I kind of want to get your thoughts on that a little bit.
Yeah, I mean, there are several dynamics that are going on there. When you begin to talk about higher population density operating areas, so by definition, suburban and urban areas, and even this idea of urban air mobility, UAM, is a concept that's been developed by NASA and by the FAA as a way to define an operating model for using drones and eventually air taxis to move people and larger goods with larger autonomous aircraft, essentially, in urban areas. There are advantages and disadvantages from a safety model point of view. So one of the big advantages you have is that you already have obstacles through which aircraft are not typically flying at high speed, right? So if you've got buildings and you have office towers and things like that, you already have obstacles through which you're not going to have high-speed aircraft moving. But you then have to worry about lower speed, low altitude aircraft like helicopters and other things that may be traversing that area. And the idea of not having radar covering all of those areas, that's really important because radar is not suitable when you have a lot of obstacles, for example, that you can't see through and things will be traveling around those obstacles. There are definitely a variety of models emerging. One is acoustic sensors, which tend to be good for detecting that there is an aircraft somewhere in that environment. We think that's really interesting, and we have partners that are working on acoustic detection. And then, of course, there are coordination systems. So there's the idea of the Unmanned Traffic Management System. This is a set of rules and protocols that NASA developed and that the FAA is gradually investigating and researching and then hopefully demonstrating to do coordination so that you have inputs into a networked system where you can receive information about air traffic, and then you can use that in your drone flight to remain far enough away from that air traffic. And so for urban flights and urban traffic, it's likely that that'll be an important tool. We're using a wide range and mix of sensors and other data and other cooperation from aircraft who've also registered in that system. Hopefully, eventually, all of the crewed aircraft will also be registering in some way, being tracked probably automatically by that system to provide that additional level of safety in higher density areas. There are other concerns with higher density areas. If you're flying over people or over roads routinely, the FAA has indicated, and the rules require that you have special mitigations, meaning usually at this point you have to have a small parachute system so that your aircraft can do a lot less damage if it falls out of the sky, for example. Those waivers are being issued for what are called flights over people. That's been great. We actually were providing some safety during some of the first flights that validated that new system and standard in North Dakota in 2018 as part of the initial integration pilot program that the FAA launched and have since replaced with the Beyond program, which is also the FAA's advanced research program. So there are several things when you start doing urban flying. The other thing that's really important, Craig, that I'm sure your question points to, is you really need a high degree of autonomy to make this work economically.
Right.
So if you're going to be flying all over a city and you need a lot of drones doing work, everything from inspecting buildings, doing construction supervision and monitoring resources and movement, traffic, and then, making deliveries between hospitals and clinics. Right. We have some projects like that we're involved in. You really are going to need to be coordinating that, and you're going to need to have a lot of autonomy to help coordinate that so that eventually you will have one pilot in a command room, maybe 2 or 3 pilots running 10 or 20 drones. And there's a lot of experimentation going on with that as well. And that's where we think our system, for example, really shines, where you have automatic safety. So it's going to detect and tell you about a conflict before it is a critical need, and you can perform an avoidance maneuver well ahead of that conflict.
Right. Yeah. So let's talk about UTM. I think the acronym gets thrown around quite a bit. I think some folks talk about it as a sort of as a safety tool. Some talk about it as an efficiency tool. I'm curious from your perspective, where does let me back up. So the traditional aircraft version of air traffic management, right, ATM, is completely cooperative. It's mostly folks that need access to high density areas where there are traffic management procedures in place, and they need to be put in line or they're not going to get to go there, period. Right. So how do you see, you don't have to participate in that, but there's value if you do, if you need to go to those areas. Do you see unmanned traffic management operating the same way, or is it going to be an instance where if you want to operate in these zones, whether you're an aircraft or a drone or whatever, you're going to have to be providing data to that system, and non-participants, even though I know politically that's challenging to force every aircraft owner to install equipment. It's been a challenge with remote ID. It's been a challenge with ADS-B. Do you think that changes at some point and folks are just going to eventually be required to provide that data to the UTM system?
Boy, if I had a crystal ball, right? Right. That's the $64,000 question. So we as a company, we are enthusiastic about UTM as a way to provide coordination and to enable autonomy across an entire UAS ecosystem in the United States, and for integration to the national airspace system, a way to have drones participate that is rational and planned and coordinated and cooperative is going to be necessary, right? So depending on how you define it and when you think it might be viable, are very important questions. But we definitely think there's going to be some form of UTM that is used eventually in the U.S. All the problems that you mentioned about universal adoption of all the equipment and the data that would need to be fed from all the aircraft into the system and from all the drones into the system, all types of drones at different altitudes with different types of missions and different type of models, those are huge challenges to implementing that. And so we have seen generally in our discussions and the things that we've been involved with the FAA and NASA that there is a tendency for operations, meaning flights and companies that want to do longer flights, to use more equipment and to provide more data out and to make themselves more visible and to provide better safety for themselves, to make themselves safer when flying around other aircraft, are able to get those permissions. Okay, so that's already happening today, like leaving sort of UTM as a special case and hopefully a future path for all of that. And that's we for example, we participate in flights where we're providing radars, either portable or using large radars. We are providing all the systems to receive ADS-B and the radar to receive signals, tracks from aircraft that are not using that transponder. And we bring that all together so it can be seen in one place. UTM is similar to that, but it's to share that data across all different types of users and servers, like a cell phone network. That's really what it's usually compared to, where you can pick up your cell phone. You don't need to worry about how it's going to be routed. Your call is going to reach somebody else on another cell phone, on another network, somewhere else with a totally different model. You don't worry about any of that because there are standards and all the systems are interconnected. We think that they're going to need to be interconnected systems, and gradually encouraging people with incentives, which is really what the FAA generally has tried to do, to join those types of systems and use those resources, is how we think that's going to happen. We're already seeing that. So, for example, a radar coverage for an area through a service like ours, our Flight Horizon product, can then service UTM users, right? We can provide that information and then provide additional safety services about what we're seeing from that radar into an overall unmanned traffic management system. So we definitely think there's a path forward with that. What's happening now is it's happening in silos and it's happening in islands, essentially. And that's where the level of experimentation is right now. And the industry is moving very quickly, though, to develop more comprehensive flight areas, corridors, for example, which are really exciting. You and I are aware of some important corridors that are being developed specifically around these kinds of systems.
Right. So let's talk about Vigilant's product, Flight Horizon. You mentioned it. Can you walk us through kind of what it does, why it's important, and where do you think it'll be used in the future?
Yeah, absolutely. So Flight Horizon is our product here at Vigilant Aerospace. It is a software product. It's based on 2 NASA patents, and it is a product that does detect and avoid and airspace management with UTM capabilities. So it takes in information from transponder receivers, from radars. We integrate with a wide variety of radars, plug and play out of the box. It integrates with FAA data, so it pulls in FAA data from the overall national system to help serve aircraft, drones that might need to fly higher. We work with the military in some cases, and they do have aircraft, of course, that fly as part of the National Aerospace System. And then it can pull in weather information, pulls in all of your air class information, and turns that into one big picture. And so that can either be used as an onboard unit to do detect and avoid, to provide avoidance commands directly to the autopilot. If you have a large enough aircraft to have some of these sensors as they exist today on your aircraft, which some operators do, or alternatively, it can be used on the ground. And so we'll have either portable or fixed radars on the ground and receivers, and then our online data all can be brought together and fused together into that picture so that remote pilots and airspace managers who may be running a whole team of remote pilots can see that airspace, can be told about conflicts with a predictive system that's looking at trajectories and giving them a picture of what that remote pilot needs to do to immediately avoid that conflict, and have what's called a resolution advisory in your sort of TCAS or ACAS terms. So it's an avoidance command that's generated based on the prediction of where those aircraft are going to be. And that's based on industry technical standards. And that's really what we focus on. So we do software to do that. We've had a very, very positive reaction to the software. It's increasingly used. We've had contracts with the FAA. It's used on an ongoing basis at NASA. And increasingly, we're also seeing it used with the Air Force, and have a couple of significant projects with the Air Force.
Yeah. Very cool. Anything, as we wrap up here, anything that's maybe on the horizon or that folks should be thinking about kind of over the next year or two that'll be important to pay attention to, kind of as we close up?
Yeah, absolutely. So, the thing about drones that we've always seen, and this is true of all new technologies, is it's all impossible until suddenly it's happening, You know,
right.
That's what we're seeing with this is a really rapid acceleration in the use of some of these technologies and the advancements of the technologies themselves. The idea that eventually you can put an entire radar essentially on a chip, that's on the horizon. You know, I mean, you know the advancements with cell phones. It's really amazing, and those types of advancements are starting to accelerate in the types of technologies that are going to enable these advanced operations. And so we watch that really carefully, and we work really hard with our partners to be at the forefront of adopting those technologies. And so we just think that this is going to accelerate quite rapidly over the next several years, and that some of these things that look really difficult now are going to become possible. And so you will have drones that can do things for you suddenly that you didn't realize they can do for you. So we're really excited about that.
Yeah, very, very interesting. And we're watching as well on this end. Kraettli, I really appreciate you hanging out with us for a little bit and kind of enlightening folks on what DA, UTM, what all these things mean and why they're important. And really appreciate it. Thanks for joining us. If you'd like to be a part of the UAS Cluster Initiative community and get access to more of our content, check us out at www.uascluster.com.